Hello and welcome! In this lecture we're going to add a nice visual to our grid. It's going to be very dynamic so we can easily show or hide only the positions we want, and later on we're also going to add various colors for our various actions. Alright, so in the previous lecture we already built the logic for calculating the valid grid positions. Right now this is my selected unit, and I can only move to valid grid positions. So if I click outside the grid, nope, I can't go there. If I click on the same one, can't go. If I click on top of the other one that is occupied, also can't go. And if I click outside move range, also can't go. So now let's add a visual to know which positions we can move to. For that, let's make a new C# script. Call this the grid system visual. And let's actually place this inside the grid folder. Okay, now a game object to run it. So let's create an empty game object with the same name, attach the script, and reset the transform. Alright, there it is. Now there are many ways that we could create a visual. The most performant way would be to dynamically create a single mesh for each grid position, so one quad on each grid position. That would be the most performant, but also quite a bit complex. So let's start off with the simplest method possible. Then in the future, if we run into performance issues, then we can refactor that code. But for now, let's start off simple. And the simplest method possible is to just spawn a prefab on each individual grid position. So here in the editor, let's make that prefab. Let's create an empty game object. Call this the grid system visual single for a single grid position. Then inside it, let's create a 3D object. Let's make it a quad. For the texture, there's a downloadable texture for this lecture. Go ahead and download it. It's a Unity package, so just open it. Make sure it is selected and import it. Here it is inside the textures folder, the grid. As you can see, it's just a simple square texture with a bit of an outline. Let's make a material for it. So under materials, let's create a brand new material. Call this just grid, and like we saw previously for the unselected visual, let's just drag the texture over here on the base map, and on their surface type, make sure you select transparent. Now let's apply this grid to our created quad, so let's apply this material. Okay, there it is. Now just rotate it to face upwards, so let's put it with 90 on the X. On the parent, let's put it also on a Y of 0. And now here again, we see the same issue, so let's add a slight offset, so maybe 0.03. Then for the size, let's make this occupy the size of an entire grid, so that's actually 2 units. And again, remember what I said in the very beginning, separate the visuals from the logic. So all of the changes that I'm doing here, note how I'm doing it on the quad, on the child object, and not on the parent game object. So this one still has a scale of 111 and no rotation, it's all on the quad. And also here, let's get rid of the mesh collider since we don't need that. Okay, so just like this, if we position it, let's say on 002, we can see what it looks like on top of a grid position. The underlying grid texture already has the size of the actual grid. So by the way, note how the texture is drawn slightly smaller with a transparent border. This is really just a personal preference, I quite like it like this. But this is just a visual, so if you want, you can modify the image file, it's just a basic PNG image. If you want it to occupy the entire space, you can just modify it and expand the size of the actual square. Or you can even just play around the quad, so set the scale maybe 2.1 or 2.2 in order to make it occupy the entire grid position. So like I said, just personal preference, and personally I quite like it like this, so make it a tiny bit smaller than the actual grid. Okay, so with this we have our simple single object. Now let's drag it into our prefabs folder in order to make this into a prefab. Let's delete it from the scene. And now let's open the grid system visual script. Okay, so here first up, let's add a reference to our prefab. So let's make it a serialized field. Let's make it of type transform, call it the grid system visual single prefab. And here in the editor, let's drag the reference, okay. Now all we need to do is just cycle through the entire grid and create a prefab on each grid position. So let's do 2 fors to cycle through the entire grid. And again, since we're going to access the level grid, let's make sure we only do it on start, because again, we're accessing an external reference. So let's go for int x equals 0. Then here we need to do x under the width, which means we also need to modify the level grid to expose the underlying grid system width and height. So let's go into the level grid script. Here it is. And let's expose it pretty much the same way that we did all of these pass-through functions. So let's go inside the grid system, and up here on the grid system, let's expose the width and the height. So let's just make those, so a public int get width, and we just return the width, and a public int get height, and we just return the height. Okay, so now again, back into the level grid script, and over here, let's make some more pass-through functions. So one for the get width, return an int, going to the grid system, get the width, and same thing for the get height. All right, so we have these two functions exposing the width and height. So now we can go back into the visual. For the x under, let's go into the level grid, access the static instance, and get the width. And now cycle through the z. Alright, so here let's just spawn the prefab. So just call instantiate, pass in our prefab reference, so the grid system visual single prefab. And for the position, let's go into the level grid to get the position. So get the world position for this x and this z. The function requires a grid position, so let's create it. And finally, we don't want any rotation, so quaternion.identity. All right, that's it. So let's test and see if we have a visual single on every single grid position. And if there it is, we do have a single visual on every single grid position. All right, awesome. Now what we want is to pretty much only show which positions are walkable and which are not. So we want to show some and hide the others. For that, we really just need two behaviors. So first, the ability to hide every single grid position visual. And then we need the ability to show only a selected list of grid positions. So in our grid system visual script, let's make those functions. So we're going to have one for hide all grid positions. And then we're going to have another one, also public void, show grid position list, and receive a list of grid position. Now implementing these is going to be our challenge, but before that, let's make a class to handle each visual single prefab. So back in the editor, let's make a script. So inside the grid folder, let's create a new C# script, call it the grid system visual single. Then let's select the prefab and attach the script onto it, okay. Now in this script, let's add a field for the mesh render. So let's do that. Let's do a serialized field, private mesh render for the mesh render. Then back in the editor, let's go inside the prefab and let's drag the reference. So the reference is the quad reference, okay? And now when we instantiate the visuals, let's store a reference to this script. So let's go back into the visual, okay? Let's do very much like we did on the grid system. So let's make a two-dimensional array to grab all of these scripts. So up here, let's make private. We're going to store of type grid system visual single. And it's going to be a two-dimensional array. Then before we cycle, let's instantiate this array. And here we need the width and the height. So for that, let's go into the level grid. So level grid, in order to get the width. And then same thing to get the height. Okay, so we have our array. Then over here, let's instantiate and grab the reference to that object. So we get that one. Then on the array, on the position xz, let's put the reference of this one, and we do get component and get the component of that type. So the grid system visual single. All right, so we have this array with all of the components of grid visual single. So with this, it's almost time for your challenge. Let's just make one more thing. So over here, let's just make two functions. So public void show, and then a public void hide. Okay, so everything is set up for you to complete this challenge. All right, so go ahead and implement the show and hide functions on the grid system visual single script. And as a hint, do the same thing that we saw previously, so use meshRender.enable. Then also implement the functions on the grid system visual. And finally, use the testing script to show only the valid move positions. Okay, so that's your challenge. Go ahead, pause the video and give that a go. Alright, welcome back. So let's write all of these functions. First up, let's go into the single script to make the show and hide. So over here on the script, this one is super simple. So for the show, meshRender.enabled, just set it to true. And on the hide, we just set it to false. Okay. Next up, let's go into the grid system visual script. On this one, let's make the function. So first of all, the one for hiding. Let's cycle through the entire grid. So let's copy pretty much the exact same cycle. So we're cycling through the X and Z. And then we already got the instance right here inside of here. So we go into that one and we just call hide. And next, for the show grid position list, we just cycle through this list. So a list of grid position. Then we access that one on the X and Y. So grid position.x and the grid position.z, in this case, just call show. All right, so finally, let's go up here into our testing script. So we had this for testing, so press the T key and it gets the valid grid position list. Now let's use this and call those functions, which again means we need a reference to the grid system visual. So again, let's implement the singleton pattern. We can copy the code that we already used previously. So for example, here on the unit action system, let's copy the instance. So up here, then let's copy the awake, just like this. Okay, so now we have a static instance, just need to change the type. All right, so we have a static instance. Now let's go into our testing script. And over here, first thing, let's hide. So go into that one, go into the instance and hide all of the grid positions. And then after we do, then let's call the function to show the grid position list. And then we pass in the valid grid position list from the move action. All right, so that should do it. Let's test. So here we are, and by default, all of them show. Now as I press on T, and yep, there you go, it does work. So for this character right here, these are the only two valid grid positions. I cannot go here, cannot go here, 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 or anywhere out here. So I can only go to these and so on. Okay, great. Now the obvious next task is updating. Right now, if I move here, the grid visual isn't updating. So let's do that. And for that, let's take this code out of this testing script and put it on a proper grid visual. So let's go into the grid system visual, and up here, let's make a proper function for this. So let's make a function, call it update grid visual. Now we're going to call this whenever the visual needs to update. So for example, whenever a unit moves or does any action or the selected unit changes. Now in the future, we're only going to update when necessary, so only when those things happen. But for now, let's just run this on every update, so it will always update every frame. So for that, let's make a simple update. So private void update, and on update, just update the grid visual. Okay, so now here, let's copy the code that we placed in testing. So pretty much exactly this. And since we're inside of this class, then we no longer need the static instance. We can just call the functions directly. Except of course, here we see an error. So right now we have no unit reference. This is meant to be the current selected unit. So for that, we can ask that on the unit action system. Here we have the selected unit, and we already have a function to expose it. So on the grid system visual, let's grab a unit reference for the selected unit. We go into the unit action system, access the instance in order to get the selected unit. And then we do the same thing. So go into the selected unit, get the move action, and get the valid action grid position. Also again, this code will be refactored later on when we add some more actions. We're going to eventually end up without this kind of going through the unit to get the action. But until we get to that point, let's do it like this. So with this, everything should still be working exactly the same as previously. And yep, there it is. We do see these two. And now if I try moving the unit here, let's see if these update. So I click, and yep, there you go, it does update. So now on this position, I can move into any of these. And also since we made it dynamic to select any other unit, if I select the other unit, yep, there you go, it automatically updates. And this one by default has the 4 movement units, so I can move anywhere except on top of that position. Okay, everything is working, so we can actually reset the movement's max distance for this unit. So let's exit play mode. Let's select the unit, and on the move action, we changed it to 1 just for testing. So let's right click on the component in order to reset the modified component. So under modified component, just revert the changes. There you go, reverts to the default of 4. So if we test again, yep, now this one can move up to 4 units, and same thing for this one. And of course, they cannot move outside of here, so into invalid positions. Nope, can't do it, can't move too far, and can't move on top of another one. Alright, so here we built a really nice visual for all of our actions. We have the move action validation that we made previously, and now we also have a visual to show us which positions we can move to. And also, of course, the code is all super well written, so we can easily define which positions we want to show and which ones we want to hide. This means it will be super easy when we add some more actions, and each will have different valid grid positions. Our next task is going to be exactly that, adding some more actions, so let's do that in the next lecture.